Hello and welcome to section 6.3, which is on proving that a quadrilateral is a parallelogram. Theorem 6.8 states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Opposite sides are congruent, then the quadrilateral is a parallelogram. Theorem 6.9, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So if you want to look at this picture right here, so this one says if both pairs of opposite sides of a quadrilateral are congruent. So if this side is congruent to this side and this side is congruent to this side, they're saying it's a parallelogram then. This one, theorem 6.9, says that this angle right here, if it is supplementary to both this one and this one, those are consecutive angles in a row, then it would be a parallelogram. Theorem 6.10 says that if both pairs of opposite angles of a quadrilateral are congruent, so this angle and this angle are equal, and this one, those would be opposite each other. If both sets of those are congruent, then the quadrilateral is a parallelogram. So knowing those rules, we can go ahead and work our way through this example. So it says, for what values of x and y must EFGH be a parallelogram? Okay, so we know that 4x plus 13 right here, this one has to equal this one, and then this one has to equal this one. Okay, another way you can look at it is we know that consecutive angles have to equal 180. So this one plus this one have to equal 180, and this one plus this one have to equal 180. And since you have your x here and your x right here, you'd want to add those two together, because otherwise you're going to have an x and a y, and then you're going to have a system, and that's going to be more work for you. So we're going to go ahead and we'll do F and G first. Those are consecutive angles. So 4x plus 13 plus our 12x plus 7 has to equal 180 degrees. So 4x plus, supposed to be an x there, plus 12x is 16x. 13 plus 7 is 20. And that's going to equal 180. And I just go ahead and solve this two-step equation by subtracting 20. So I'm left with 16x equals 160. Divide by 16. Your x equals 10. Okay, so that's part of what we need to know. Then we also need to solve for y. And we're going to do that by using this angle and this angle, because they are consecutive angles, and consecutive angles have to add up to 180. So y plus 10 plus 3y minus 2 equals 180. Combine your like terms. Y plus 3y is 4y. A positive 10 minus a 2 is a plus 8 equals 180. I'm going to minus my 8, giving me 172. So 4x equals 172. I'm going to divide by 4. 172 divided by 4 is 43 degrees. So 43 equals y. So this and this, now we can plug in to get, oh, I take that back. It doesn't say we need the angles, so we don't need to plug that in. We could, though. We could plug this 10 in here. So 4 times 10 is 40. 40 plus 13 is 53. If you plug the y in across from it, 43 plus 10 is 53. So guess what? 53 equals 53. So it did work. And then you could check the other side as well. 12 times 10 is 120. 120 plus 7 is 127. You could check it this way. 127 plus 53 is 180. And 127 plus 53 is 180. If you plug the y in for this one, it will also equal the 127. So there we have, using our three rules there, solved for x and y. Theorem 6.11, if the diagonals of a quadrilateral bisect each other, so cut each other in half, then the quadrilateral is a parallelogram. Theorem 6.12, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So basically they're saying if you can prove that one set here is parallel and congruent, guess what? The other side is going to have to be. If they're both parallel and congruent, there's no other choice but for the other ones to be parallel and congruent. So my example here, can you prove that the quadrilateral is a parallelogram based on the given information? So given angle ALN is congruent to angle DNL, and angle ANL is congruent to DLN, and I have those marked. This one is congruent to this one is congruent to that one, this one, which those are alternate interior angles, which we have talked at length about in our previous chapters. So I just went ahead and finished this, but I'll go through and explain it here. So ALN is congruent to DNL, that's given. ANL is congruent to DLN, that is also given. So if I know that both sets of those angles are congruent, from there I can say that AN has to be parallel to AD. AN has to be parallel to AD. Why? Because alternate interior angles, right, are congruent. And AL has to be congruent to ND for the same reason. LAND is a parallelogram. Why? It's the definition of a parallelogram. The alternate interior angles proving that it's parallel. If two sets are parallel, it's a parallelogram. So you've gone through it in not very many steps proving that. So bring that knowledge with you. We'll talk about it more the next time I see you. Have a good night.